Okay guys, it's me Imad. So today in this video tutorial we will learn about how to generate or how to make a PWM waveform with the help of PIC microcontroller. The programmer which we are using is the Proteus Design Suite 8.9. So how we can do that? First of all, we need to open the Proteus simulator. Click on this new project and it will lead us to the window of or circuit window. So we write here pwm underscore gen. Okay, it is the name of our project. Yes, and next and next and next, finish. Okay, now this is our circuit window. Here we need to click on this part section and click on this P, and we will then search for our microcontroller, and here it is. Okay, PIC16F877A. You can even use some other 16F series microcontroller. So here we will go. Okay, no need. We can go and we will just take our power supply, which is this, and we need to connect it with the mClear or VBB pin, because if you will not give 5 voltages on this mClear pin, the controller is not going to work inside the simulator. And one more thing, that for simple operations like PWM, here this microcontroller can even run without these oscillators. Okay, and one more thing, that is our oscilloscope. With the help of oscilloscope we can observe the PWM waveforms. So we will go and we will click on this this C2. Okay, and C1 and C2, because these two are PWM pins of this microcontroller, specifically designed PWM pins. Okay, and if you don't know about the PWM or pulse width modulation, you must know that one simply means that it is the width. Okay, width of the waveform. Okay, because on x-axis it is time. Okay, so for how much time it used to be on, it is called as the duty cycle. Okay, and obviously the rest of the time the signal will be off. Okay, let's see. Okay, we will go, and now we will go for our microcontroller programming. We will go and we will click on this micro C Pro for PIC. Okay, this is our programming language, and here we have to wait for a while. Now it is open. We will click on new project. Here it is telling us standard project, so click on next. Microcontroller has already selected, and here we will write pwm underscore 0001. Okay, so now we will click on next, and this is our wideman function. Here first of all we need to go to our view and library manager, and here we will select our PWM library. Where it is? Here it is. Okay, so it is selected now. Now in void main we can write pwm 1 underscore init 5000. Okay, now what is this actually? Okay, this pwm1 underscore init is a function, okay, which is taking 5000 as a parameter inside its body. Okay, and this function is actually used for the initialization of pulse width modulation 1 pin. Okay, that is C1 pin, and we are not going into how this function used to work, because obviously inside this function there are multiple interrupts and timers and all these things. Okay, but we just know that it used to initialize our first pin of PWM. Now we will write PWM 1 underscore start. Okay, underscore start. And this line or this PWM1 underscore start function is actually for to start our PWM. Okay, and what about the duty cycle? Now obviously we have to adjust the duty cycle, and now we have written while one. Why? Because we want an infinite loop. Okay, because we want again and again a PWM signal to be sent to pin number 1. Okay, pin PWM1 pin. So here we will write PWM1 underscore set underscore duty, and here we will write like a 30. Okay, like 30. Now we will write here delay of 50 means that 50 millisecond delay. We will run it out. We will click on save. Okay, they say delay underscore millisecond. Okay, they said 50 like this. Okay, so we can write this and this. Okay, now we have to create hex file. Okay, and here we need to click on this save function. Okay, wait, save function, and here we will write PWM underscore chan underscore 0. Okay, so this is our hex file. Okay, now we will again go to our circuit, and here we will double click on here, and we can select this hex file. Now hopefully it will work for us. So click on this run sign, and now you can see that we are getting our pulse width modulated waveform. Okay, and one more thing that you can see that now, okay, duty cycle is obviously 30%. Now we will try to increase it out with the passage of time. So here, or we can just write 60 here. Okay, what will happen now? We will see. Okay, save and this, and now when we will run our circuit, now you can see that our duty cycle has increased to 60%. So in this way we can create any duty cycle with the help of our microcontroller, that is 16F877A. So hopefully you got the concept. So thanks for visiting our channel, and don't forget to subscribe.